So we had finished with decorator and we're ready to hit up the next design pattern. This is going to be the last of the group of 3 that we'll design a project around. And this will be much more my design than a lab that has an API. It should have a lot less overhead, I guess. So you're not going to have a particular API. I'm not going to tell you how to do it, but instead I will more than likely give you, here is the associated high-level behavior that we need. Here is what we need the user to be able to do. Program it in such a way that it is encapsulated, that it is safe, that it uses all 3 of these design patterns. And that will give you a little bit of creative freedom in terms of exactly how you implement it, but making sure that you stick to the important things, which are using the design patterns and thinking about the design of your code. So that 3rd design pattern is called Builder. And I can already tell I haven't quite animated these correctly. I did it very quickly while multitasking on the way before class. So the motivation behind the Builder design pattern is it's another one of the construction ones. So we've talked about strategy, which is more behavior oriented. We're kind of encapsulating behavior. We talked about the decorator, which is wrapping things up. That's kind of behavior driven as well. This is our first one that's really going to look at object creation. And the next one we go into, factory, will also be, it's one of the main ones for object creation. So whenever you're looking at creation or object creation, we find ourselves looking at constructors and trying to figure out what can we do with constructors, or how can we manipulate a constructor, or how we think of a constructor so that we can get a better outcome in object creation. Because as it stands right now, the base use of the creator, the new operator, is it does some work and it returns you that object. But what if you want to put a different hierarchy in that? What if, there are lots of what ifs in there, and we can get a lot more out of the concept of a constructor if it lives as a class and not as just a method. We get some additional functionality if we can make our constructor have an inheritance hierarchy, or we can make our constructor adhere to polymorphism, or these kinds of things we get from classes that we don't really get from methods. We'll more so talk about that with factory, but for builder, this is more so when you have a large, complicated structure that you're trying to construct. So one of these is going to look at a vacation planner. So you can identify when you want to use this by looking at a long constructor parameter list. A long constructor parameter list means that we need a lot of information from the user as we go to construct the object. The user needs to send us lots of information. So you can imagine vacation planning. It's going to be a 3-day vacation, and each day needs an associated hotel, needs an associated number of park tickets. This would be to something like Disney World, where the park tickets can be to any of multiple different possible parks. So on day 1, we attend Magic Kingdom. On day 2, we attend Animal Kingdom. On day 3, there are 5 parks in Disney World. You may want to change up the days in which you visit different parks based on your particular reservation. And then there's a particular place where you can go to dine. And maybe that's for lunch, maybe that's for dinner. There are also potentially special events on some days. Maybe you want to go to, this is called Patterns on Ice. You can imagine now some kind of ice show that involves people dancing to design patterns. Ooh, strategy. It gets ridiculous quickly. I love this book for many reasons, but each day can have combinations of optional or non-optional elements to the reservation. And we want to be able to construct this entire object. And you can imagine just how much information you would need from the user to be able to construct this big object. Here's the name of the hotel you're going to visit on day 1. Here's the name of the hotel you're going to visit on day 2. Here's the name of the, I guess there's no hotel on day 3 because it's the day you leave. But here's the associated list of the days of the parks. Here's the associated places we're gonna go dine. Here's the empty string whenever we're not going to go dine in this location. Here's an empty string when there's no special event. It would just be this long list of parameters that you need to be able to produce this object. So we need some way to make this just a little bit easier on the user so they don't have to give quite as much information, or a better way to communicate that, because if your parameters are out of order or you provide something with a typo in it, then there's going to be a big issue to the constructor because it's not going to be able to parse the input correctly. Wow, this didn't animate at all. Yikes. I got partway into this. We'll play with it. So normally we have a constructor to be able to do this. Instead, now we're going to utilize everything that a class has to offer. So there can be different configurations of vacation objects. So here's a vacation where day one, we stay at the Wandering Inn. Maybe people know that reference. Anyone know that reference? The only one. Ooh. It's a lit RPG series that I'm actually currently reading, but it's the longest series of books that has ever been written, as far as we know. It's at over what, 10 million words now and counting? It's long.
Longer than Wheel of Time?
It's more than twice the length of the Wheel of Time.
Jesus.
Yeah. Wheel of Time is very long, 13 books, but yeah, anyway. Just randomly threw that in there because. So day one, we stay at the Wandering Inn, have tickets to Magic Kingdom, have no special event, and have dinner at Castle Diner. Day two, etc. So how many subclasses would this contain if you wanted to be able to construct multiple different possible configurations of your vacation? Lots, right? If we wanted to pair all of that together and have a subclass that represented a particular reservation type, we would have to limit it to, well, you can only stay at a couple of different hotels because otherwise it's going to explode in complexity. You can only eat at a couple of different places because otherwise it's going to explode in complexity. We basically have to multiply the number of possible hotels by the number of possible configurations of those hotels, because you don't necessarily have to stay in the same hotel for both days. It's just an exploding number of subclasses. One observation that you can use here is rather than decide everything at once, we could do it in a sequence of steps. And you can imagine that as being like a multiple different constructors called for different elements of the reservation as we continue to build it. So we could have something like a build day method that builds a single day, an add hotel method that adds a hotel to an existing reservation, something like this. So a builder, the actual builder object and the builder pattern, is an interface that's going to exist, and we're going to have classes that stand alone within this interface that are apt at constructing a particular kind of object step by step. And that way we arrive at the final version without having to know all of that information from the beginning. So we can think about this as a separation of concerns. Only the method that is doing the adding needs to worry about what is there. So we end up with a structure that looks kind of like this. So the client is going to construct the entire planner. The builder is what then interfaces with the abstract builder, which knows how to build a day, add a hotel, add a reservation, add a special event, add tickets, get the vacation planner. And the client doesn't have to worry about any of that. They just have to interface with the builder to be able to go through the associated steps so that the builder can do all of the logic of adding it to the reservation object. So the user is just like clicking a button or selecting from a dropdown or something that's really easy for them to do. And then everything that's going on behind the scenes is being handled by this builder object. So the vacation builder is a subclass of your abstract builder interface that has a particular vacation field, a vacation object. And then it also has the actual logic and specifications for how we're going to go about doing that. So client says to the builder, construct the vacation planner. The client is an abstract interface used to build the planner. The concrete builder has all of the logic inside of it to create the actual vacation object and store it in the vacation structure. And then the client is going to use things like builder.buildday, builder.addhotel, builder.addtickets. And now there's not necessarily an order that this needs to be done. Remember that with a long parameter list, we would need like the hotel for day one, the hotel for day two, et cetera, in a particular order. This allows you to parameterize that, and then the user can build their reservation step by step. And then the only logic that you need is this a complete vacation, yes or no? And they continue doing steps until they have built the entire vacation. And there's no order specified for that. So it does not have the same constraints as a method used as a constructor. Does that concept make sense? You're basically generically asking them the question, what do you want in your vacation? And then you tell me in the order that you care about how you want to construct that vacation. So you don't have to specify the hotels first. Maybe that's the last thing you want to decide. You could start building the vacation without knowing anything about the hotel. You just can't book everything until you specify everything.
So it'll build upon itself in whatever order you want.
Kind of, yeah. Like we have all of these methods here, build day, add hotel, add reservation, add special event, add tickets. All of these things that don't depend on each other. These are all independent tasks. And rather than having to specify them in a particular order, we can now specify them in an arbitrary order as long as we have some logic that says, yes, this is a complete vacation, or no, it is not. You don't want to book a vacation without having a hotel. You don't want to sleep in your rental car. You don't want to sleep on the street. You want to sleep in a hotel somewhere. You could, but what kind of site would let you do that? What kind of site would really let you do that? That sounds like it's probably more likely that someone would arrive at their vacation and go, oh no, we forgot to add a hotel to our reservation. And that would.
I'll work it out.
You're designing this for other people though, not for yourself. Even if you are personally willing to go sleep on the street during vacation, most people are not. So we kind of want to give them a red flag that says, you're doing something you probably don't want. This is not a complete reservation.
Magic Kingdom Castle.
Yeah, there we go. Sleep in Magic Kingdom. What else is that castle for?
Oswald's gas station, I'll just sleep in there. What are they gonna do? No.
So once again, you can see that this is a UML diagram. We can get a sense of what the code implementation, the class structure looks like by reading this as a UML. One thing to note is that you don't necessarily have to be constrained to a single builder. There may be multiple ways to construct the same object using the same steps. As an example, there's a vacation, but there's also a luxury vacation that has some optional steps to it. The luxury vacation has a taxi waiting for you at the airport to pick you up. It has a suite in a hotel rather than just a room. And so you could have builders for different kinds of vacations where you select, I would like to plan a vacation, or I would like to plan a luxury vacation. And then you have different constraints on what a vacation is or a luxury vacation is. So you can have multiple different concrete builders that inherit from the same abstract builder. So now we would have an abstract builder interface, and then we'd have a concrete vacation builder and a concrete luxury vacation builder that would build the associated vacation or luxury vacation, depending on whether the user wants a regular vacation or a luxury vacation. So you can make use of the fact that this is abstracted into an interface and have multiple builders that inherit from that same interface, as long as they adhere to the same methods. And we know this about interfaces, right? Whatever methods you write in an interface, those need to be specified in all of its concrete subclasses. So as long as the abstract is there, that's the hardest part of that design. Questions on that concept? There's this weird concept that is optional in a builder called a director. If we had the prior implementation and we wanted to be able to have both a vacation and a luxury vacation, the client is still responsible for making sure that every field, everything in the vacation is actually filled at the end. That becomes the client's responsibility. If we wanted to offload that, it's kind of the job that a travel agent might have. Someone whose job is making sure that you've thought through everything and planned for your vacation appropriately, rather than it just being on you and you deal with the consequences if you didn't make a complete vacation. So the director is going to be the logic that makes sure that everything is there. Or if there's any order to those steps, like for instance, if you need a reservation at a particular hotel in order to dine at that hotel's restaurant, you would, if no order was specified, be able to specify that I'm going to eat at this hotel's restaurant and then say I'm going to be sleeping somewhere else. And that wouldn't be allowed, but because of that, it's really hard to constrain all of the order of those things in the logic of your builder. It's much easier to abstract that into the content of a director that's going to make sure that all of those constraints are upheld. You can't make a reservation at this particular restaurant unless you're also sleeping there. So here is the final pattern and everything that it looks like. So we have the client communicates directly to the director. The director instantiates the builder. The director is the only thing that can change the builder. So you only interface in ways that the director allows you to interface, which constrains the user to only be able to do what they're supposed to do to be able to create an appropriate vacation. The builder has all of its concrete subtypes. The client just has to choose which concrete builder they're going to use. They will realize that, and we're using realization here to say that I want to plan a vacation. Well, now when the director talks to the builder knows to create a regular vacation. Or if the client says, I want a luxury vacation, then the builder knows to instantiate a luxury vacation concrete builder. Does this concept make sense? The client is only communicating through the director, and the director has the logic that constrains the building process. So we have kind of some steps here in gray as well, some ordered steps. I don't know if we can really see the fact that there are numbers associated with them. That kind of gets cut off on the board, but they do go in order. So from top left to bottom right, it just says the builder interface declares product construction steps that are common to all types of builders. 2 concrete builders provide different implementations of the construction steps. Concrete builders may produce products that don't follow the common interface. Products are the resulting objects that are produced by the concrete builder. So this is like when new returns an actual object to you, the concrete builder will return the product. Using the prior example, it'll return the vacation object instantiated with all of your vacation preferences of everything that you've selected via the director that made the builder, that instantiated it with the appropriate kind of builder, and then instantiated it with all of your preferences. That object gets returned as, here's the vacation object with all of your vacation in it. Zoomed in. Here's an example of something that's not a vacation and how it might work. Zoom in, please. There we go. So this is a car builder. The client wants a car made for them. So the director knows how to either make an SUV or make a sports car. Note that the user at this point shouldn't be able to say something like, I want an SUV with 1,000 seats. As cool as that would be, that's not something that is possible to produce. So the client can't communicate that directly because they shouldn't be able to call set seats at all. If the user has that power, then they can do ridiculous things. The director, on the other hand, knows exactly how to set the seats if it wants to make an SUV, and it knows exactly how to set the seats if it wants to make a sports car. So we cut off the client from the builder and have it only interact with the director that puts the associated constraints on the project. The user can select, I want an SUV or I want a sports car. The builder knows how to make each one of those things, and we have a car builder and a car manual builder, one of which produces the car and one of which produces the manual for the car, that inherit from the same things. So this produces a car, this produces a manual. It can set the associated number of seats, and this will produce the eventual manual that tells you how to operate the car with this particular engine and this particular trip computer and this particular GPS. And it makes the associated changes to the manual in this class, and it makes the associated changes to the car in this class. And what it produces off of the same interface is the actual car and the manual that you put in the dash. Does that make sense? How there might be some constraints that you don't want the user to be able to directly influence? The director is just kind of an abstraction of the process for the user to be able to communicate with the builder, when you don't want the user to have full power over the builder. Questions on this example? So when should we think to use the builder pattern? We have some kind of overloaded constructor with a bunch of possible ways to call the constructor. So we have a constructor that takes no parameters, or a constructor that takes one parameter, or a constructor that takes two parameters, or a constructor that takes 18 parameters. Just that by itself probably tells us we need a builder. But if we have a bunch of different ways to construct the same object, overloaded constructor, lots of different constructors written, and a lot of those steps are the same, that tells us that we want to construct a bunch of different types of the same product, right? There are a bunch of different ways to do this construction. So maybe it makes sense to factor out all of these constructor methods and put them into a builder. Because this also helps with extendability in the future. If there are new ways that you want to be able to create these objects, like if we look back at the last example, maybe we want to, in addition to making an SUV and a sports car, we want to be able to make a van. We want to be able to make a truck. We want to be able to make a regular passenger vehicle. It's not a sports car. We want to be able to make a budget car. There are lots of different kinds of cars that you'd want to make. And if you're overloading a constructor, maybe you have to write a new constructor every single time you do this. Whereas with this, then you just have the director say, what is the difference between an SUV and a regular car? And you could make those associated changes in the director that mention the steps that already exist in the builder. And then you can build the manual for that at the same time without having to specify all of the different logic for each different car. You interface with what you already have. It's a great way to abstract it. The other thing you can do with builder is you don't have to make the object when you call the constructor. You can build an incomplete object and wait for some decisions to be made before you finally construct the object. If you're just using a constructor method, the constructor method needs to return an object, which means that you need to be done with object construction by the time you finish your constructor. Maybe some of your fields can be set to null that can be changed later, but that creates some issues with, you might later expect there to be something there. It's really difficult to make a partially complete object in a constructor. But within the builder framework, it's really easy to create a partially complete object. because it adheres to whatever the director is saying. So the director could specify that a partially correct object is fine there, then you know you have a partially correct object. So it helps if you want to defer some of these elements of object construction to later. Some benefits and some detriments, as always with design patterns, there are always detriments to consider. It's not just benefits. Some of the benefits though, no way for the client code to access the unfinished product. The product needs to be finished before the client can interact with it. So you don't get things like null pointer exceptions when you try to drive the car that doesn't have an engine yet. You could have a partially complete car and be waiting for a new engine to come out before you put that new engine in the object. Get started on the car's construction, put the engine in later. That would be possible with a builder object. But the client is not going to be able to get in the car and try to drive it off the lot before it's complete. So the client needs to wait for the builder to finish all of its steps, but the builder can place that on hold. Step-by-step object construction, very nice. Recursive construction steps, you can't do that. In a constructor, you can't have a constructor call a constructor. That doesn't really make sense, but in the builder framework, you can absolutely have a builder inside of a builder. So you can recursively build the components with a builder. That is possible. You can reuse the same construction code. This is very useful if you have very similar kinds of objects, like making an SUV, or I guess maybe a sports car and a budget car are very similar in construction, except for the engine that goes in them and maybe some of the aerodynamics of the car. But in general, there are a lot of construction steps that are the same. So you could factor that out within a builder and allow for the repetition of that. It also adheres to an important design principle that we call the single responsibility principle. So the single responsibility principle says that each class has a single responsibility. The construction code should not go in the same place as the business logic of the product. So now they're done in separate classes. The detriments, of course, you have multiple new classes. So your overall code complexity increases. It's more difficult to understand. But you also have the power to create in a lot more steps, or you have a lot more control over the object's creation. Questions on the builder pattern? This is one that's actually pretty brief to go over. There aren't a ton of complexities when building it up like this. The next one will be significantly longer, but one other thing that I want to do before we run out of time, we have 10 minutes, thankfully. Questions that I can answer while I pull this up? No questions. So I've mentioned before just how good of a resource Refactoring Guru is. This is the Builder Refactoring Guru page. So I want people to be able to see this. I see the question in chat. I will get to it momentarily. So here is the builder. You're kind of you're putting different steps there. So you can imagine that to build a house, there are a bunch of different steps to building a house, and people may not want every one of those. Maybe you want a house with a garage, but without a swimming pool, and then you can see that the house with a swimming pool doesn't have a garage. Maybe you want a house with a swimming pool and a garage, but they're all independent. You can kind of build each one of these independent of every other process. So rather than making a single constructor with a bunch of different Booleans, yes, I want a garage. No, I don't want a swimming pool. Yes, I want a fancy statue. Yes, I want a garden. Something like this. Then you can produce the builder object that doesn't have something like new house, the number of bedrooms, the number of bathrooms, this is a massive constructor call. So this is what tells you that you want to use the builder pattern because the constructor is just really gross or would need to be overloaded with a bunch of different possibilities to produce different houses. So this again tells you that you can deconstruct the construction of a house down to its individual components. And then you could also distribute those to different processes to say, one of you is responsible for putting the walls together. One of you is responsible for this. It allows you to parallelize your work as well. And it also allows you to separate things that can happen at the same time. It doesn't matter whether you build the walls first or you start constructing the swimming pool for something that has a swimming pool. You can get started on either one of those first or do them at the same time even. So it allows you to be able to show that kind of logic. So here's the concept of a director that we talked about. And then you can see directly where I pulled that image from earlier on the slides. It came directly from Refactoring Guru because I think it's really good. It allows you to see the exact UML. So this should be your first stop if you don't understand something about one of the design patterns that we go over, or you want a quick recap. It's kind of the Wikipedia of design patterns, except it has a bit better information in general than Wikipedia does. It's a little bit more reliable, but it describes everything that we're going over in this class. It also gives you some pseudocode that helps you to be able to construct these. So you can see that we have cars and manuals again, just like we did before, and you can see the exact pseudocode, and you can even, at the end of it, see things like how to implement, some pros and cons, some relationships with the other patterns, and at the very end, there's some code examples in any language that you might care for. So if you click on Java, you can see Builder in Java, and you can start to see what this looks like in the associated language. So this has some example code for you to play around with. This shows you the exact layout of the car builder. It shows you the exact layout of the code that you would need to be able to produce this for the dummy example that we are using in class. And that will pair one-to-one with anything that you need to be able to implement using this. So once again, Refactoring Guru is a phenomenal resource. I highly recommend this is the place that people go for self-study. The lectures in this class, because we don't have a ton of time to go over this, are mostly going to be conceptual in nature. And if there's an issue going from the conceptual to how do I exactly code this, happy to address that in office hours. But Refactoring Guru is also a really good resource for this as well. If you prefer self-study to being social and talking through it with somebody, this is a reasonable resource. So again, highly recommend checking it out. There's a lot more embedded in this than I have time to go over. What can I answer? We have about 5 minutes left. I don't really want to dive into factory yet, but I'm happy to answer any questions for the last 5 minutes of class. I will tackle the question in chat first, which is, do I do voice calls over Discord if we need help after hours or after the class? And the answer is yes, on an as-needed basis. So let me know. I can try to be available. I do appreciate work-life balance, so I try not to do too much after the working hours. But if you have questions during working hours and you're unable to make it to campus for actual office hours, I can absolutely set up Zoom with my whiteboard, and I can walk you through some stuff on the whiteboard, or voice calls over Discord if it's just a call. So let me know how I can be of assistance, and I'm happy to meet you halfway based on your limitations as well. What else can I answer?
You said you're assigning a lab later today.
Yeah, I want to get the decorator lab out as well. So the mini labs are going to be very much the same format as the strategy lab that you have now. I don't yet know how they're going to break because I'm kind of assuming that something that worked last quarter is going to work again. I haven't had time to dive in and actually figure out, all right, what's wrong with this? So I apologize if something is wrong. It seems like there might be one of the tests that don't work well in the strategy, rather than coding to the tests where you modify the tests. Instead, either try to modify the code so that it works, or if there is an issue with the test, let me know. And it's okay if something you submit has one test failing if the test code is not great, considering I did not write that code. It'd be good to know so that I can communicate that to the people who did write this so that we can fix it and make sure that it's in a good state next quarter. I just have not had time to go through and design something that is my own, which is what I really want to do. I will do that for the bigger projects. Other questions? All right, I guess we can get out of here, and I will see you tomorrow. We will start diving into factory. Other thing to note, we have an exam on Friday. So the study guide is posted. You'll want to get started looking at the study guide. I'll take a few minutes at the start of each class to go over any questions people have. If there are any practice problems, particular kinds that you would appreciate, let me know sooner rather than later. I can spend a little bit of time digging up some practice problems. Let me know how I can be useful for that. And I would like to also have a day this week that's just kind of a work day, since I'm assigning multiple labs at the same time. Have a time where I can answer your questions in class, you can make some progress, talk to some friends about how they're going about it. So there will be some work day at some point this week.
Will we also get a note card for the exam?
Yes,
Okay.
yes, note card just like before. I have some extra note cards in my office. If you don't have them, you can swing by and get one.
With the note card front and back?
Yes, front and back.
In your office tomorrow.